All right, let's talk about RISC-V then. So there's been a lot going on with RISC-V in the first part of this year. And perhaps this is a good opportunity to talk about what has actually happened, why it's happened, and what do we think is going to happen in the future. Just to introduce myself, if you've not come across me before, I work inside of the Red Hat Enterprise Linux business unit. I work in the ecosystem team, which is headed up by Ron Pacheco. And one of my responsibilities is beginning the process of mapping emerging technology into the Rhel roadmap. And as you might imagine, RISC-V is classified as an emerging technology, which is why I get to talk about it today. So what I'm going to run through is, why do we care about RISC-V anyway? What is it? I'm not going to spend too long on that. I'm assuming that if you have an interest in RISC-V, you pretty much know what it is. I'm going to talk about where we're at in terms of hardware and software. Probably talk more about hardware than I will about software. Then I'm going to talk about the availability of Rhel on a RISC-V platform. Then talk about Fedora and what our plans are for CentOS, and then take questions. So that's the agenda. So what is RISC-V? Why should I care? Like I said, I'm not gonna spend a great deal of time here. Red Hat's interest in RISC-V is driven considerably by the fact that it's an open standard machine or instruction set architecture for a machine. And I think that RISC-V is going to become very popular because of the fact that it's going to have a very open audit trail of what's in the hardware, because the instruction set architecture is so open and the definition of that instruction set architecture is out there to be found. I think that one of the features that we're going to see from the hardware vendors is that they'll be able to demonstrate the provenance of the instruction set architecture on any particular piece of hardware, and can show an audit trail that demonstrates that there are no instructions inside of this piece of hardware that shouldn't be there. That said, the fact that RISC-V is an open instruction set is a great thing, and it's part of the reason why I think there's so much enthusiasm inside of the Rhel business unit for RISC-V. Is it feels very synergistic that we are layering open source software on top of an open standard instruction set. I stopped short of calling RISC-V the hardware equivalent of open source, because even though the definition of the instruction set is open, most of the vendors that are building RISC-V cores are not making those RISC-V cores open. So I'm kind of wary of using the phrase open source where as applied to RISC-V, but it's definitely an open standard, which is what makes it important. RISC-V, now an international organization based out of Switzerland that is promoting the RISC-V instruction set. It's interesting to note that RISC-V is, apart from being promoted and curated by RISC-V International, it isn't owned in the same way that other hardware proprietary technology is. So again, I think this is another one of the keys to its success as we start to move forward. The communities that we, Red Hat, are involved in, so we are a member of RISC-V International, courtesy of IBM. IBM are the paying member, but they've handed over the responsibility of that membership to us. We, Red Hat, are also a member of the RISE project. So if you're familiar with the way that the ARM architecture came forward. You'll remember that or know that there's something called Linaro, which defines the standardization of different parts of the ARM hardware environment, such that it defines a standard for software. That's very much what RISE is doing inside of the RISC-V ecosystem. We're also a member of the Open Hardware Foundation because we certainly thought that we would see hardware coming through the Open Hardware Foundation that would form the basis of developer platforms, and we're also a member of the CHIPS Alliance. So where are we with hardware? So 2025 has been an interesting year for RISC-V hardware. We've actually seen systems now that are viable as developer platforms for what I would consider to be general purpose software come forward. Later, we'll talk about what we've done with Rhel 10 on a developer's platform, but it almost feels like every day, if not every week, there's a new announcement going on inside of the RISC-V ecosystem of different vendors moving forward. Tens Torrent, for example, very, very prolific in announcing availability of different pieces of hardware. RISC-V is also going to be considerably important inside of the automotive world as well, with Bosch announcing a fabrication plant over in Europe specifically for RISC-V. And yeah, more about the Open Hardware Group and the CHIPS Alliance there. This year we saw a RISC-V laptop appear, and that laptop from Deep Computing is currently available with Fedora 42 on it. There's a variety of form factors of hardware coming to the market based on RISC-V now. I think the takeaway from this is that the RISC-V hardware market is accelerating very, very quickly. I'll talk a little bit in a minute about the business unit's prediction of when we might see data center style hardware. I think what we're seeing now is a significant acceleration of hardware availability. One thing that I would comment on is what we're seeing from RISC-V hardware is more cores as opposed to faster clock speeds. And I'm sure anybody involved with hardware will have a good understanding of why that is. But that certainly seems to be a trend. And as you can see there, there's a machine there with 16,000 RISC-V processor cores as part of its design. The communities, so I think I've talked about this. RISC-V International, we are a member through IBM. We're also very active in the profiles and platform special interest groups, which again make up those standards that we have an interest in. Jeffro, who was going to be presenting this to you, serves on the RISC-V board as an elected representative on behalf of all of the strategic members here, and the RISE project. The RISE project, as I mentioned earlier, it's very similar to Linaro. In addition to myself sitting on the board of directors for RISE, Brian Harrington, also known as Redbeard to anybody close to him, also chairs the distribution integration working group inside of RISE. So all of the Linux different distributions are represented there, I believe, including Fedora and the Open Hardware Group. So what happened just recently? The Red Hat business, or Red Hat Enterprise Linux business unit, decided before Christmas of last year that we were interested in building a developer's preview for the next release of the Rhel operating system. And so that would have been Rhel 10 back there. And we were looking for a hardware platform to build it around. And we selected the Hi5 Premier 550, try saying that very quickly, as the platform of choice. And so from, I guess, the beginning of January through to Red Hat Summit in May, there was a huge effort made to get the implementation of Rhel 10 up and running on this RISC-V board. This is a very similar thing that we did when we Red Hat first took the steps to introduce support for the ARM architecture, and I think we did that back in 2007. Well, I want to say it was at the transition of Rhel 7 to Rhel 8, I think. Back then, the preview that we built, the developer's preview that we built, was only available to industry partners. So this would have been like OEMs. And we took the decision this time around that we'd make the developer's preview available to anybody that wanted to use it. So it's freely available, freely downloadable. And as you can see there, you can pick this all up from developers.redhat.com product/RISC, Rhel/RISC-V. There's a great set of documentation that goes along with the bootable binary image and the sources for that, which defines stuff like how to set up that hardware prior to trying to do the first boot, and the firmware updates that have got to be made to the board prior to starting work on it. Just that documentation alone, I've been told, has been very well received inside of the RISC-V community. But anyway, we now have an implementation of Rhel 10 on a RISC-V developers platform. We announced this at Red Hat Summit, and probably the question that I got more than anything else during that period was, why now? Why are you doing this now, Red Hat? Because that developers platform is probably about the performance level of a Raspberry Pi 4, maybe a little bit more than that, but that's about where it's at. So that's certainly not data center enterprise server ready stuff. So Red Hat, why are you doing this now? And the reason is that we anticipate that we're going to see data center ready hardware available on the market during probably 2027. And that might feel like it's a long way away, but it's really not. And so the decision was taken, like I said, just before Christmas of last year, that we wanted to do something with RISC-V, really because we wanted to kickstart the community around Rhel and RISC-V, because if you did believe that we were maybe 24 to 18 months away from seeing data center class hardware coming into the market, that really wasn't very long to begin to build up a developers community. So that was the reason that we did what we did, and why we did it when we did it was to try and generate as much runway towards a developers community as we possibly could, which is why we're now going to talk about Fedora and then later CentOS support for RISC-V. I think the thing that I want to highlight about the Fedora environment is that we've been working with Fedora on RISC-V for quite some time. There's been, I think Fedora 38 and 39 were available on RISC-V platforms, although the platforms at that time were pretty rudimentary. And you've seen now Fedora support, Fedora 41, Fedora 42 support appear on RISC-V platforms. The same platform that we use to build the Rhel 10 developers preview currently supports Fedora, and Fedora 42 is available on a number of other platforms. The point that I want to make about Fedora is that RISC-V is not a current official architecture. So there's a couple of different places where you would go to pick up Fedora images for RISC-V devices. There's Fedora Rocks, which is from David, and Fedora vForce from Fu Wei, a Red Hat employee over in Shanghai. What I'm hoping that we're going to be able to do by the end of this calendar year is find a hardware platform that's performant enough to use to bring RISC-V up to the level of an officially implementation with Fedora. What we don't want to do is drag down the performance of everything, so we'd have to hold up the availability of a new Fedora release because of RISC-V. So we're looking for hardware that's performant enough to do that. There's a number of different platforms that have come forward, and in fact, when we were at Summit, we had an ultra RISC device which had come into the country in the personal baggage of a Red Hat employee, and we had CentOS 10 up and running on that ultra RISC system at Red Hat Summit. That ultra RISC system is fast enough that I think it may be the basis of the platform to bring RISC-V to be an official architecture for Fedora in this calendar year. But what we're trying to do just this quarter is to set up a CentOS build environment using those Sci-Fi P550s that we purchased for the implementation of Rhel on that platform. The difficulty with doing this at the moment is getting all of the patches needed to the 6.12 and 6.15 kernels pushed upstream. Sci-Fi are on the hook for doing that, and it seems to be a very slow process. So clearly we're not going to be able to set up the build environment for CentOS or get an official Fedora implementation until all of those patches make their way upstream, so that at least it's a completely open source environment to put this forward. But that's our intention, is to certainly get full Fedora support by the end of this calendar year, and by the end of this quarter have a build environment for CentOS that we can share with the rest of the community. What I would say is that we're unlikely to do any more work with Rhel on a RISC-V platform until we start to see hardware that is compliant with a RISC-V specification called RVA23. And along with RVA23, which we think is the minimum requirement for enterprise servers, along with RVA23, we'd also like to make sure that all the firmware management is done with UEFI, and that the boot protocols are ACPI compliant as well, because really our intention is to try and make sure that we have the hardware foundation to be able to build a single bootable binary that will boot across multiple platforms, instead of having to have the boot time code individually constructed for each platform. So that's it from me. I hit the 20 minutes there, which I think which isn't doing bad. I'll stop sharing and see if we've got any questions. Deathly silence.
So if you're all doing the thing with the stuff, with the getting people to do standardized RISC-V stuff, can we
doing the thing with the stuff? Yep.
Yeah, with the booting and the computers and the startups and the beeping.
Yeah.
But seriously, right? So the challenge that I have dealing with a lot of alternative architecture stuff is that the only platforms I find myself quote unquote liking have been so far the x86 platform and, to almost everyone's eternal surprise, PowerPC. Because those two platforms have not regressed back to the 80s where you have to figure out what's on the hardware before you can start the hardware. What I would love to see, I guess this is more of a comment rather than, and a little bit of a plea, is this, maybe, Red Hat as being part of this as an early participant in the RISC-V processes and in RISE and all this stuff, is pushing to make UEFI plus ACPI cheaper, so that regardless of form factor, regardless of target, that unless it's like a super embedded case, that is the default thing people use, rather than us like going down rabbit holes with things like U-boot and other things like that. Like my personal feeling about this is that when you're using, if you decide that you need to use U-boot and device tree, you've messed up. It's a failing of the hardware platform, that the operating system needs to know what the hardware platform is at that level of detail, because it makes it super hard for people to really dig into, to even take advantage or use new hardware and stuff like that. Like my experience dealing with this with Fedora Asahi Remix, and we'll talk a little bit about CentOS Hyperscale Asahi in our Hyperscale talk in a little over 10 minutes, is that because we have to know everything about everything, and we have to have everything like sketched out, we have to have all the hardware, we have to have all the software, we have to have all the knowledge. And like in x86 and PowerPC worlds, this is not how that works. You can know enough about the system and then reuse generic stuff, and it can probe and it can figure it out, and it interrogates the platform and sets things up. I would love to see a slightly less myopic view of RISC-V, in such that IHVs and ISVs and everyone gets on board with this idea that you need that kind of parity in the platform. I care about that even more than performance, because performance can be fixed down the road. Making the actual bring up good, if you don't do it early on, it'll never get fixed. We know this from ARM, that it never got fixed. And I want to see this fixed very early on in RISC-V, because I see the platform failing if they don't, because there's not much to win on.
And if we've got to construct a separate boot environment for every single piece of hardware, it's not going to be successful. We're already in a situation where, with a lot of ARM edge devices, those ARM vendors are deviating away from the Linaro standards, which means that the operating system needs tweaking to boot across a lot of similar but just slightly different devices.
Exactly.
Which is a real pain. And
that was my nightmare fuel when I was an embedded developer a decade ago, and I would not like to see this repeat again. Like, RISC-V is young enough that it can be excused that it's like this in the beginning, but it's also mature enough ecosystem-wise that there's no excuse that they aren't pivoting.
Yep,
so
agreed.
So I would love to see this, like, especially, I would love to see from Red Hat's participation in this ecosystem, pushing it not just on the server end, but also on the client end and the single board computers and all this other stuff. Because the big mistake I think we made 10 years ago is that we decided that servers were the only target that this mattered on, and it had nasty side effects for basically everyone else. In my personal opinion, I think it caused ARM development to stagnate for a really long time, because without effective, accessible, and reliable and customizable hardware platforms for people to use, it made it so that having effective development for that architecture took way too long. And I don't want to see that happen with RISC-V.
Yeah, agreed. I think that the RISC-V environment is accelerating very quickly because it's building off the experience in the community that was developed with ARM.
I hope so, because the early days of this, and I sit in some of the I poke in some of the RISE meetings. I'm in on the list and whatever. And my worry is that they're making the same mistakes this go around too. They're talking about, we just only need this in equivalent for the server spaces because that's where software and hardware are decoupled. But the reality is that software and hardware are generally decoupled everywhere where the manufacturer isn't the producer of the software for everything anyway. And outside of Apple, no one is a single hardware software producer. And it seems that there's the same myopia that affected ARM. I'm seeing the early signs of it also affecting RISC-V, and so that's why I wanted to say, like, can we, make sure that there's more of a push, because you guys are super important and relevant and all in the place, making sure that people recognize that this is a real problem. Like, even these new Windows on ARM devices, we're struggling to support even one of them, because even though they in theory have ACPI, the ACPI is broken, so Linux has to boot through device tree, and we're in this nightmare fuel all over again.
Yep. The good news was that when I first got involved with RISC-V, Intel was also very active, and I want to say this was a couple of years ago, because almost all of the RISC-V startups were fabless, and they were anticipating using Intel Foundry services as the mechanism to actually get product made. And so Intel were very instrumental in, putting their stamp of UEFI, for example, into the RISC-V community. Unfortunately, Intel have got other things to do now, and so their focus on RISC-V, for example, isn't as great as it was. But Neil, I completely agree with you, and it's certainly something that inside of Red Hat we're very focused on trying to do.
Yeah, I also would like to see the people that do the Fedora vForce come into the Fedora RISC-V SIG, because, I continue to be surprised at the efforts that are going on outside, and it's great that there's outside efforts that are interested in Fedora, but I really haven't seen anything from them coming into Fedora proper, and that sort of concerns me, in the sense that, what if they have patches or fixes or doing stuff in that front? And I understand that this is like mentoring with college students and whatever, but getting them involved in upstream projects is, I think, a good habit for them to develop early on. And so, I don't know anything about how the Fedora vForce thing is going, but and that's actually the larger concern. It's like, I don't know what the heck's going on there.
It's just a band-aid at the moment until we can get RISC-V adopted as a platform. But and believe it or not, I actually have a meeting this afternoon to talk about that.
Okay, cool.
So I'll represent your point of view, Neil.
Excellent. That's great. Fortuitous timing.
It is. Alrighty, we're at the top of the hour. Anything else before I hand back over? Alrighty.